Hello, everybody. This is the lesson for part 2 of normal distribution for my grade 11 applied students. And okay, so maybe we should have a quick look back at part 1 of the lesson where we learned about the normal distribution density curve. We learned the 68, 95, 99.7 rule that tells us that when we're looking at a normally distributed set of data, it fits in this curve. The mean is right down the middle. 68% of the data is between one standard deviation to the left and to the right. So in other words, 68% of the people will fall in this part of the graph. 95% fall within two standard deviations, so that's this part of the graph. And 99.7% fall between three standard deviations, plus or minus. So 99.7% of the population, whether you're doing things like measuring their height or their weight or their SAT scores or anything else that would turn out to be randomly but normally distributed, 99.7% of them are in this shaded area. Less than 1%, in fact, less than 0.15% to the left and to the right are past three standard deviations. So that's what we learned about yesterday. Today, well, how can we tell if data is randomly but normally distributed? How do we tell if we have a normally distributed piece of data? Well, we have two strategies. Strategy number one might come as a surprise by how easy it is. Look at it. That's basically it. We'll make a graph and we'll see if we have something close to a normal distribution. Now, it's a little beyond the scope of our course to make density curves. So we're kind of still stuck with histograms. But keep in mind, a histogram that is normally distributed is still going to look pretty much like this. I mean, here, I'll just doodle over it a little bit here. It might have, let's see, where's my pen? There. It might have a bar here that's a little higher, and then a bar right next to it that's a little lower, and then another bar that's a little higher again. But overall, the general shape of all of the bars of the histogram should follow this general shape of the bell curve. And if it doesn't, it's not normally distributed. So, hang on. Don't want to mess up my diagram too much. So, let's see what we can do. Go back to, oops, that's not what I wanted. I didn't want search, go away. Go back to part 2. Okay, so everybody in their notes is on part 2 of normal distribution. And let's start by showing graphically whether or not this is normally distributed. It could be. No, I noticed just by looking at the frequency table that most of the data is in the middle, and then it kind of trails off to the left and it trails off to the right. Right? So it could be. It's a contender for being normally distributed, but I kind of want to see a graph. So we'll do this two different ways. We'll use the TI calculator and we'll use the histogram generator at imath.com. So we'll do the iMath one first. So go to my blog if you need a refresher on where to find that. And remember at the top, I have a list of all of the things we've been using, and this is the one we want. We want the histogram generator. And okay, so we're going to put in the numbers for the histogram generator. So how many classes do we have? Well, the lower limit looks like it's 5, right? So we're going to put a 5 in here. The class width is 1 because we're just counting by ones for this data. The number of classes, it's 5, 6, 7, 8, 9, 10. So 5, 6, 7, 8, 9, 10. That's six classes. And the width and the height, don't worry about that. It'll figure that out for you. And then when you hit prepare frequency table, it'll give you, there you go, from 5 up to but not including 6, from 6 up to but not including 7. So basically all the 5s are here, and there's 49 of them. Is it tab? Tab. And then all the 6s are here. There's 79 of them. All of the 8s are here. All the 7s are here. There's 135 of them. All of the 8s are here. There's 154 of them. All of the 9s are here. There's 154 of them. And all of the 10s are here. There's 81 of them. Hit graph it. And there's our graph. Feel free to sketch that and put it into your notes. I'm going to cheat. I'm going to just cut it and paste it into the notes. That's not fair. We can't do that. You guys make a sketch. Okay, so make a little sketch. And there we go. I'm going to edit. I'm going to copy that. And I'm going to put it onto my notes. Right there. Might have to play with the, let's see, paste. Let's see. And let's see, can I move it up? Oh, but I can't put a picture on top of a picture unless I start playing with the transparencies. So anyway, you're going to make the sketch here. I'll just leave mine here. And what do you think? What's your opinion about this shape? Does that look like a bell shape to you? No, it's not a very good bell shape. Okay, so that's me using the online frequency generator. I have a question. That's a good idea. It's probably not a bad idea to write in the numbers. So make a sketch. And actually, I would put the numbers actually in the middle of the bars. This is the 5 bar, the 6 bar, the 7 bar, the 8 bar, the 9 bar, the 10 bar. Okay. All right, now where's my calculator, peoples? And that includes the people. There's a few people now who have downloaded the, maybe I shouldn't be saying this online and something people could see publicly. They have found a way to put the TI-83 calculator onto their smartphones. Miracle of science, that is. So those people have something that looks very suspiciously like this. And okay, so how do we do this? There's a previous video where I show how to do this, but I'll run through it one more time. It doesn't hurt to have the data again here and have the steps on this video. So we need to first of all put the classes in here. So class 5, class 6, class 7, class 8, class 9, and class 10. And then I'm going to put the frequencies in the next column over, L2. And in list 2, so let's see, there was 49 of those, and there was 79 of those. And this is really exciting, but I'm not gonna stop it. It'll only take me a minute here. Feel free to fast forward if you're watching this at home. 154 of these, and 154 of these, and 81 tens. So what is this again? This is shoe sizes. So they did the survey of shoe sizes for everybody in the school, and nobody's passed a size 10. What? Remember, there was a basketball player who was actually size 23. Could you imagine that? Like, I have big feet that are clumsy, and I'm only size 12. Anybody bigger than a 12 for shoe size here? You got a 13? Yeah, I actually wear a 12, but I kind of have to, it depends on the type of shoe. Sometimes I'm kind of squeezing into them because my feet are kind of wider than normal. So yeah, I probably could wear 13s in some things. And then once you get past 13, good luck. Anybody got a 14? Good luck. You pretty much have to order your shoes special in most stores. What does the guy with a 23 do? Yeah, I think every shoe that person ever had would be custom made, I would think. All right, anyway, there's my data. Do you remember how to do this? We would like to make a histogram. So first of all, we check to make sure that there's no algebra in here that's going to mess us up. And then we go to stat plot. And stat plot 1 is already on, which is good. And stat plot 1 is going to graph a histogram. So if stat plot 1 isn't on, move your cursor to on and then hit the enter button, which will put it on. Then scroll down, in case you're not there already, to the histogram. Turn on the histogram. Histogram, the default setting will probably be that the X list is L1, and then the frequency might just say 1. You've got to fix that. You have to tell the calculator, no, the frequencies are in list 2. So put list 2 for the frequencies, and again, to find list 1 and list 2, you hit second function, and there they are right there on the 1 and 2 buttons. So once you have this, you hit graph. Don't panic when it doesn't look like much of anything, because the window is not looking at where it needs to look at. So here's how we're going to fix that. First, we're going to do zoom, and then stat is, I think, is it 9? Yes, zoom stat is zoom 9. Hit that, and even that won't do a great job. You know what the problem here is that the bars have gaps in them. I don't want gaps in the bars. You know why the bars have gaps in them? Because the scale isn't counting by ones. Can you see that? X scale is counting by 0.5s. Why zoom stat thought that that's what I wanted for this graph, I don't know, but it's not what I want. So change the scale to ones. And why the graph goes to -46 when there's no negatives in the graph, I have no idea. I don't like it when my x-axis is right on the bottom of the screen, so I will put a few negatives in it, like maybe -2. Good enough. And then it does have to go pretty high, right? The highest number in my data was 154, so 180 or whatever they give me. That's a good number. Hit graph now. Oh, wait a minute. X max, though. Again, I don't like my bar to be right at the end of the screen, so I'll go to 11 just to give it a little more breathing room. And there. See, there's a nice little bit of breathing room here. And there we have it. There's our graph. And notice it's pretty much the same as this guy. This one's stretched out a little because the scale is stretched out. But notice, compare the relative sizes of the bars, and we've got the same graph. Okay, go back to the histogram generator. Okay, so back on the histogram generator. I have a question to go back to the histogram generator. Here, let me just clear it. And how about I'll pause the video and I'll run through it again. Be right back. Okay, we're back. And I was just showing people a second time how to get this on the online app. And here's the same graph on the TI. So I would even maybe now make a little sketch of this if I was using the TI in the little graph that I have. Here, let's do that. I'll make a sketch. So let me see. We'll go back to here, and let's go back to there, and then let's put the calculator up. And let's move it over a bit. Okay, and then we'll flip this over so I can draw. So let's see. We have a bar here, and then one that goes up a little more. And I actually do know what these numbers are, right? But okay, these are the 5s, these are the 6s. And then what was the next bar? The next bar goes up quite a ways. Bigger jump. There's the 7s. And wasn't the 8s the same size? No, the 8s jump up a little bit. It's the 8s and 9s that are the same size. So 8s jump up a little bit. And the 9s are the same size. Gesundheit, person who sneezed in my class. And then lastly, the 10s. What were the 10s here? The 10s are a little bit higher than the 6s. So just go across to the 6s and then go up just a very slight bit more. And there's the 10s. And that's good enough. I could label this as shoe size and frequency. And I could say, again, I could put numbers on this, right? What was this 5 number again? This was 49. So I could put the 50 there. And this was the 100. This is just past 150, so I could count 50, 100, and this is, well, that's probably not far enough, but you get the idea, 150. There we go. Beautifully done graph. Okay, question. You should put some numbers on it. Again, it doesn't have to be we're letting the technology do the work. I'm not making you do a nice scale graph like we did in lesson 1 of histograms, where we did one on grid paper. I'm not going to make you do that on the test. The question was, do you have to put numbers? Yeah, you should put some numbers in your graph so that I know that you understand what the graph is saying. Okay, now, what would a normal curve look like? Well, a normal curve would look like this, right? It would go up, and then in the middle, and then it would come down like that. What do you think? Is that close to a normal curve? And I think we all agree, not very. So I think our conclusion here, I'll write the conclusion underneath the chart here. You can write it beside your little sketch of your graph, is that this is not, and I can't spell the word very, not very bell-shaped.
That's our conclusion.
And how about not enough of the data is symmetrical to the middle. There's a name for this, right? It seems to be bulging a little bit on this side. We call that skewed. Skewed to the right. If it was a little better balanced and more of this bulge here was shared by the left side of the data, I might change my mind and say then it's normal or it's close to normal, but this is not close to normal. This one here especially, this one, this is egregious, right? Too much data on the right-hand side of the middle of the graph. So I might even say again, skewed right. And then the final conclusion, therefore, not normally distributed. This is not a normal distribution. I cannot say with any predictive certainty what percent is bigger than what number based on my knowledge of how the normal distribution works, because this doesn't look like the normal distribution, right? Look at the questions you had in yesterday's homework. You could look at a graph and go, I know that, 68% of the data falls between those two numbers. And you could say that with certainty because it was normally distributed data. This isn't, so I can't say much for certain about this. Now, that's one way to do it. As you can kind of see, there's a certain amount of subjectivity to this. Somebody else might go, well, the bars are kind of close to the middle. It's almost normal distribution. Come on, give it a break. It's trying its best. So there's got to be a way that's a little more definite than just your eyeballs and a graph where the scale could be manipulated to try to make it look more normal. What if we have an algebra way? Well, we do. Flip the page. Let's do it the algebra way. To prove algebraically whether or not data is distributed normally, the percent from the normal distribution curves are used, and we usually only worry about the middle percents. Now remember how this works, right? The way it works is 68% of the data should fall in here, right? This yellow part, trying not to color outside the lines. I didn't go to kindergarten. I never learned how to color inside the lines. There we go. This yellow shaded part should be 68% of the data, right? So here's what we're going to do. We're going to put this data into our TI calculator, or we can again go to the frequency table calculator, and we're going to ask it for our mean and our standard deviation. And I don't know why this moved way down. Oh, I know why it moved down there. It moved down there because I put a graph in the way. All right, so here's the data. Let's find the mean and standard deviation. So do you remember how to do that? Let's do calculator first this time. Okay, so calculator first. I already have this data in my calculator, right? It's list 1 and list 2. So I'd like to find mean and standard deviation. Do you remember how to do that? You go to stat, calc. It's one variable statistics. We're only measuring one thing. What's the size of somebody's shoe? But there's two things that we have to worry about. There's L1, which is the list of all of the shoe sizes, and then put comma L2, and the calculator knows that those L2 numbers are the frequency numbers, and then it does all the calculating for you. And there it is. My mean is I'll round to 2 decimal places. 7.81 is my mean. And my standard deviation, come back calculator. My standard deviation, this is we're going to assume this is a population, not a sample. We asked all of the students, so we want sigma, which is 1.44 if I round it. So 1.44. Okay? So there we go. Now, how do I do that on the online one? I don't remember. Oh, actually, I can't use this one. Just makes a histogram. I have to use a different one. So, whoops. Where did my? Oh, right. I'm going to have to open up a ViewBlog. There we go. Okay, so let's use a different online calculator. I forgot that that one only makes graphs. We can use the frequency table calculator, because this is a frequency table. And again, remember how to do this one? 5, 6, okay, but this one likes commas, right? 5, 6, 7, 8, 9, 10, and then hit enter, and in the next row, you enter the frequencies, but it doesn't know that you're doing frequencies unless you go F, and then a colon. Now list your frequencies. And what were they again? They were 49, 79, so hang on, 49, comma, 79, comma, 135, comma, 141, comma, and 154. Oh, wait a minute. There's a difference in the data here. Oh! Yeah, there's 254s. You know what? I just realized there's a typo in the data. It's 135 and then 141. Oh, okay. Well, there, that's interesting. Can we fix that? We've already done the first day, so we'll assume that the typo is this one, that there's supposed to be 254s in a row. So let's change that to 100. Is that why your hand was up a second ago? Thanks for noticing. Change that. I don't know what happened there. Some sort of typo. Okay, so anyway, let me go back to my online calculator. I'll be with you in just a sec. There's a question in the crowd here, but let me finish this. 141, and then 154, comma. Oh, wait a minute. There is no 141 now. I changed that. It's 154, comma, 154, and then calculate. Oh, no, then I forgot there's an 81, comma, 81.
I got a really good app for that statistic
Okay.
calculator thing that you're using there.
Oh, okay, good. All right, here we go. And let's see. There's the mean, 7.81. And standard deviation, 1.44. All right, we have a question in the crowd now that I'm done all that. Yeah. Sorry, I thought you were asking me something about this. All right, so any questions on how I got my numbers?
Wait, what's this? Can you scroll down?
Scroll down again. Okay, so again, mean 7.81. Standard deviation 1.44. 2 decimal places is fine, I think, for this data. So now I go back and I do this. I'm going to make this. I got to do some calculating now. Okay, hold on. You put it in by putting the list of data points with commas, and then on the next line, you hit F for frequency, then a colon, then you list the numbers that are all your frequency numbers. Okay? Now, remember, we're not using Desmos for this because Desmos isn't great with frequency charts. You literally have to type in the number 5 49 times, comma, then the number 6 79 times. And I don't know why Desmos doesn't work with frequency and why they don't change that, but that's the way it is right now. It's the one thing Desmos isn't great at. Everything else it does better than all these other apps, really. Okay, so now that I've got the numbers I need, I'm going to do some calculating. I'm going to do some algebra. So first of all, remember that this part of the graph here, this is my mean. We should be using mu, not x bar. That's a mistake. It doesn't really matter. That's my mean. This is 1 standard deviation to the right. So it's really my mean plus my sigma. This is 1 standard deviation to the left. So it's my mean minus my standard deviation. So I'm going to find those 2 values. So add and subtract 1 standard deviation from each thing. So 7.81 plus 1.44 is 9.25. I use my calculator to help me there. And my mean minus my standard deviation is 6.37. So how many of my data points fell between here and here? Now, again, there's a little bit of subjectivity here. Where would you count the size 9s? Would you say they fall between those 2 numbers? I would say yes, because 9.25 rounds pretty close to 9. So I'm going to include, so I'm going to count all the size 9s the size, let's see, oh yeah, 9 definitely falls in here, right? Because, sorry, this is the higher number. 9's definitely in here. I'm going to count the 8s. I'm going to count the 7s. Now, how about the 6s? Again, isn't 6.37 closer to 6 than it is to 7?
Is what?
Right? So, but at the same time, all of the data that's between, right? All of the data that's in this bar I'm counting, this bar I'm counting, this bar I'm counting. Do I count this bar? I'm going to try without it. So I'm actually not going to count the 6s. I know 6.37 is closer to 6 than it is to 7, but it's still not between, right? They are between 6.37 and 9.25. So I'm kicking out all of the size 6s because they're not technically between those two numbers. So how many numbers is that? Well, let's see. 9, what was 9? 9 was 154. 8, what was 8? 8 was also 154. And 7 was 135. So those three numbers, I have to add up and then divide them by how many data points I have. Or what the total of my data, actually not the number of data points, the total of all my data. So 154 plus 154 plus 135 all over. Now how do I figure out what the total of all the data is? Well, I can just add it up. I think if I use the calculator, I think it added it for me. Let's see. The sum of all the data points is, right? 600, or the number of data points, yeah, 652 is the number of data points. Is that right? Is that how many data points there is?
What did you divide it by?
Well, I haven't done the divide yet, but I want to divide by, like, what percent of the data is this? So I have 154, I have 135 size 7s, I have 154 size 8s, I have 154 size 9s. Overall, according to this, overall I have 652 pieces of data. I think the online one counts it too. Let me just check that. I don't remember now that I haven't looked at it in a while. Does this one count all the data points? Yes. 652 data points. So I'm going to take so I have 154 data points in size 7, or sorry, size 9, 154 data points in size 8, 135 data points in size 7. Altogether, there's 652 data points. Is this close to how much? How much would it be if it was normally distributed? 68%. How close is this to 68%? Well, let's do the actual math. This is a different example than I did last time, so I'm going to have to punch buttons. So 100, open a bracket, 154 plus 154 plus 135, close bracket, divide by 652. Ooh, look at that. It's really close. I think that I'm going to maybe even reverse my decision here. So using the above curve, what percent of the data should fall within one standard deviation of the mean? It should be 68%. Find the percent of the data. It's actually 67.9%, which is really close to expected. So I think my eye test has failed me. The numbers tell a different story than the picture did. I would conclude that this data is reasonably close to normally distributed. Beauty's in the eye of the beholder. The beholder who looked at the graph, which was us 5 minutes ago, went, that doesn't look like the normal curve. It's got too much in the middle and not enough down towards the ends. But then you think about it, but the stuff towards the ends doesn't count very much towards how much of the density there is in the curve, right? Those little wings at the end of here, like that's, what is that? 0.15%? And then this guy's 2 point something percent, 2.35%. It kind of makes sense that if most of the data is in the middle, we're probably pretty close to normally distributed. But certainly when I was just looking at the graph, it didn't really look like it. But looks are deceiving. I trust the numbers a lot more than I trust the picture. Because the picture I could manipulate really easily. I could change the scale, make it look a little different. The numbers told a different story. Now, there is one thing about the numbers that I maybe don't trust 100%. And that is, I didn't count all the size 6s between those two things. Right? But other than, why didn't I? Because technically the number 6 isn't between those two numbers. Because, well, okay, that's okay, good question. Why don't you use 5, 6, or 7? Well, I could, but then I'd be looking, okay, if I was going to say, here, let's draw this. The actual mean of the distribution here, the actual mean, actually, isn't there a diagram up here somewhere? Oh, I'll just use this one. The mean of the distribution, let's go back to our calculator. What was the mean again? I don't think we ever really looked at it. Come on, you. What was the mean of the distribution? The mean was, come on, there we go. The mean was 7.8, and the standard deviation was 1.4, right? So 7.8. So 7.8, I guess we did look at it a little earlier, didn't we? So 7.8, and then, okay, so add the next 7.8 plus 1.4. We already know this number. This is 9.2. Add another 1.4. 10.6. Now go the other way. 7.8 minus 1.4 is 6.4. Minus another 1.4 is 5. There. If I wanted to include my 5s and I guess it'd be my 5s and my 10s, or certainly my 5s and my 6s. Well, again, 5 is right on the line. So where would all the 5s be? Some of them would be on this side, some of them would be on that side. I still don't know if I'd count the 5s. But if I wanted to count the 6s, how much data is there between in all the yellow part now? Now it's 95%. So now I'd have to say, does this one plus this one plus this one plus this one make 95%? And we can try that. That's not that hard to do. Let's try it. Let me shrink this here. Does 79 plus 135 plus 154 plus 154 over, what was the total again? 652. Does that make close to 95%? Let's do the math on that. Open a bracket, 79 plus 135 plus 154 plus 154, close brackets, divided by 652. Ooh, now I seem to have given a little more legitimacy to my graph prediction, that this isn't that normal. The middle was fairly normal, but the ends kind of aren't.
How did you get 652?
652 should be the total of all these.
Oh.
Is it not? 49 plus 79 plus 135 plus 154 plus 154 plus 81. Yep, 652. Right? How many data points are there? 652 of them. How many of them are within one standard deviation of the mean? Pretty close to 68% of them. So that's why I think, yeah, that's pretty close to a normal distribution. Now, how many of them are within 2 standard deviations? The number I'm expecting is 90. Ooh, I only got 80. What if I added the 5s, though? Just for fun. Does that bring us closer to 90 or 95? What if we added the 5s? Again, I didn't count the 5s because some of them would be on the left, some of them would be right. What if I put them all in this bin between 5 and 6? But I guess maybe I should put them between 5 and 6.9. But let's say that we did 49 plus. And I guess would I have to include some of the 10s as well? Because this line goes to 10.6. So let's add 81 to that. There, that's the 5s, the 6s, the 7s, the 8s, the 9s, the 10s. That should be 95% of the data. It's just us freaks that are in the top 5 percentile that have size 12 feet or whatever, right? So let's see, 49 plus 79 plus 135 plus 154 plus 154 plus 81, and then divide that. Well, that's actually going to be 100%. So that's all of the data. That's not 95%. If we just cut off those guys, how close are we now? Now what would my, oops, I meant to erase that. So take my 652 and minus the 81, and then divide that by 652. It's still not very close to 95%. Interesting. So anyway, what you'll notice about this question is that there's some ambiguity here, right? Certainly when I was just looking at the graph, I kind of didn't like it very much, and I didn't think that was very good as normal distribution. But when I did the algebra, certainly most of the data, when it comes to the check mark of things, that you'd say, I need these things to be true for it to be normally distributed. There's a big check mark under 68% of it's in the middle. Okay, question? Yep. Count the 6s and the 10s and not the 5s? Well, here's the thing though. This line here represents where the exact size 5 is. Now, you might have a size 5 and a little bit, right? Everybody's foot's probably a little bigger than that. So if your foot is a little bit bigger than a size 5, you'd probably be in here, right? But if your foot's a little bit smaller than a 5, would you cram yourself into a 4, or would you probably buy a size 5 shoe? You'd probably err on the side of comfort and go a little bigger. So I'm comfortable putting the 5s in this one, but I don't know about putting the 10s in that one, right? Because if you're a little bit bigger than a 10, wouldn't you buy yourself an 11 and just like, oh, okay, my foot's, I know somewhere in here there's probably somebody with a background in selling shoes that goes, you're going to get blisters that way. But I would think most people would err on the side of not having their shoes too tight.
That's actually true.
You think? What are you thinking?
Canada is so big.
Okay, excellent question. Somebody has gotten to the heart of this problem right here. Which answer do I like better on the test? I'll tell you this. If this question had been, use a graph to determine if you think this is normally distributed, I'd probably say no. I guess I could make the argument that it's almost a bell curve. I mean, hey, my data didn't include size 4. There's got to be people out there who have a shoe size 4. There's got to, and again, there's these mutants with size 12 feet out here. I'm one of them, right? So I could take the argument that this maybe is incomplete, and if it was more complete, it would be more of a bell curve, and it's close to a bell curve in the middle. If you wanted to argue against me and say, I don't care about your right skewing, this looks fairly normal to me, or at least on its way to being normal, but it's not a very great bell curve, just looking at it the way it is. I probably shouldn't assume data that's not there. The algebra, however, is a much better answer, because we've got the numbers that back this up. Yup, 68% is between these two lines.
I said it is normally distributed to the 68%.
Okay, the microphone probably couldn't pick up the question, but if I said, the question was, but if I said it was, and look at this answer key that says it wasn't, if it was the test, would it get marked wrong? And the answer is no, because your test question is going to say, explain your reasoning, or justify your conclusion. And that's kind of where all the marks are for something like that. I'm not going to say, draw a graph and then give me the word yes or no. I'm going to say, draw the graph, and then justify whether you think that's a normal distribution or not. So there we go. There's the normal distribution examples. That's it. That's the only example. I have a little 2-question handout with exactly this kind of question for you to try. So if there's people done the handout from yesterday, you can work on it. I might kind of come back later and go through number 1 with you. In fact, I'll work on it while you work on it. But I'll stop the video, and I'll come back once I've done that first example. Okay, so we'll just pause the video for a bit. Okay, we're back. Let me just end this video by going through how we did the first one on here. So step 1 is we have to turn all this into a histogram. So how do we do that? How do we turn this into a histogram? Well, I just entered it all into my calculator under L1, and then I told the calculator what kind of a histogram I wanted. And I guess I decided to just group them by tens. So this would be, what would this be? This would be the, let's see, what's the lowest number? Is there anything in the 70s? Yeah, so this would be the 70s, the 80s, the 90s, the 100s, the 110s, the 120s, the 130s, the 140s, the 150s, the 160s. I didn't have anything in 170 something minutes, but apparently I had something in 180 minutes. Am I right about that? Maybe I've got this wrong. Looking at the data. Oh, is there something in the 60s in here? Oh, okay, then I was wrong. This is the 60s, 70s, 80s, 90s, 100s, 110s, 20s, 30s, 40s, 150s. There's nothing in the 160s, and there is one movie that's 170 something long. There it is. So that's this guy right over here, 180. By the way, could you imagine being the kind of person who would organize the movies on their shelf by shortest length to longest length? That's a special kind of person. That's somebody that's a psychopath in the making right there. That's somebody to avoid. The rest of us would go alphabetically, or maybe group them by genre. I'll keep the comedies over here and the action movies over here. No, I'm gonna go from shortest movie to longest movie. That's a special kind of organizational person right there. And he keeps the body parts in his freezer by length as well. So that's really good. Okay, anyway, so I put all of this in list 1. Now here's the window for this. I'm going to go over it, don't worry. Here's the window for this. Let me zoom in on that for you. The smallest numbers are in the 70s, so my X minimum 70. My biggest number's in the 180, so I went with 190. This is the important number. Guys with calculators, look at this carefully. This is the important number right here, because that tells you what you're grouped by. I'm in groups of 10, so my scale is 10s. And then everything else doesn't really matter that much. And that gave me this graph. If I had been doing this on the frequency generator online, I'd have just entered everything. Or actually, I'm sorry, the histogram generator. I'd have entered all of the numbers, and then I would have told it that the class width is 10, and it would have made basically the same graph. Now, looking at that, what do you think? The last one, at first we thought it really doesn't look that much like a bell curve, but the algebra kind of proved us wrong. Think the algebra will prove us wrong this time? I don't know. Let's see. This does not look like a bell curve. Look at this. It's got this big, long, wide thing over that way. If we connected all the tops of all these, we do not have a nice, smooth curve. So we're going to say this is not a normal distribution. It doesn't look enough like this. Now, when we do it algebraically, the calculator tells us our mean. It tells us our standard deviation. One standard deviation up gets us to 126.8. One standard deviation down gets us to 82.2. So now I go through the data. And by the way, on the calculator, remember I can sort data? So I can sort it from smallest to biggest, and I add up all the numbers that are between 83. I'm not going to count the 82. Is there an 82 in the data? I don't care if there is. I'm not counting it. it's got to be bigger than 82 and smaller than 126.8. So I count all of the 83s to 126s and I add them up. That's 40 out of the 50 scores. 40 out of 50 is 80%, which is way too big. One standard deviation should be how much? 68%. So too big, not normally distributed. Okay, so we'll end this here. We'll go through the second one tomorrow. Your homework tonight is to try the second one yourself. You should probably run through this one if you haven't punched the buttons yet. And we'll go over the second one tomorrow before we start getting into z-scores. So I'll end the video there. That pretty much captures everything people missed from class today. Thanks for watching.